advanced geometry problem that they will ask. They're not going to just stick to numerical. Now, Nelson, we're going to go through this thing, and then I want you to watch this. We're going to link it to similar triangles, and then in the next segment, we can do a little bit of probability. There's so much to do. Let's quickly, without any further ado, get into this. It says there, in the diagram below, two circles intersect in B and C. Okay, so there's the circles B and C, they're intersecting. Okay, and then ABCD is a cyclic quad. That is so important. ABCD cyclic. Do you agree, Nelson, that's on a circle?
Yep.
And the important thing, but for example, if it's not on a circle, can we assume it's cyclic?
No.
Definitely not, definitely not. Okay, let's just carry on. Do you want to see what the next statement is? It says AC intersects the smaller circle of K. DC is produced, and DCT is a tangent. Okay, so DCT...
to a smaller circle, yeah.
DCT is a tangent to the smaller circle. So that guy is a tangent to the smaller circle. And we've got to prove that AD is a tangent to ABK at A. Now, ABK, if you look at this is quite interesting. We've got a very interesting situation. ABK is here, and we want to prove that AD is a tangent. So I'm going to highlight this. This is AD here. Okay, there's AD. And we've got this, ABK. Okay, now they're saying it's a circle, but you probably agree with me, Nelson, that there's an imaginary circle going through there. So let's draw it in. Okay, it's an imaginary circle.
It's not yet there. We have to prove it.
It's imaginary. We want to prove. Now, what would we need to prove if we want to prove that AD is a tangent?
And if you look at this, the condition is to prove that AD is a tangent to ABK, or to the circle that touches ABK. You must prove that A2 is the same as B1, meaning this would be tan chord theorem. An angle between the tangent and the chord equals the angle in the alternate segment. It's what you must finally prove.
Should we write that down for them? What's this? So we're required to prove. So let's put a little RTP here. Required to prove that A2 is equal to B1.
This is your last statement, guys, on your working out. Because most learners, Mark, they just take this as the final answer, and then they carry on.
Absolutely.
As long as they know that the condition is A2 is B1, they just take it and go.
and they mess this whole thing up. Okay, so A2 is B1. Now, this is important. Here's A. Okay, there we go.
Okay.
AD, let's just make this nice and clear for the viewers there, and that's K there. And this is C here, and this is T. Okay, now, we've got this. Okay, we've got A2, and we've got to prove it equal to B1. Now, the trick here, now, guys, this you must listen carefully. This can come up. Nelson, let's have a look. What do we know? We know that this is a tangent, and we've got a cyclic quad here. So what we want to do is we want to try and connect this. We definitely know, if you think about it, what do we know about C3 at the moment?
C3 is an exterior angle of a cyclic quad. Must be equal to A1 plus A2.
Okay, so let's write that down. If we go and we move it up here, let's get some paper, and we can then slot it in quickly here. If you take this, what do we know about C3?
C3 equals A1.
C3 is equal to A1 plus A2. That's important there. A1 plus
A2, you reason out.
Okay, that's because of the
angle of cyclic quad.
Exterior angle. Let's call it cyclic quad. Okay. Now, once we've done that, we've got to somehow connect this. But what do we know? What else do we know?
We know, if we're to work in the vicinity of A and B, we have K2 here, which is the same as A1 plus B1.
That's right.
K2 is A1 plus B1, which is exterior angle of a triangle.
Okay, so we've got K2
equals A1 plus B1.
That's B1, okay. Okay, now notice the connection. You see we've got A2 as B1. Now these two say, hey guys, we equal. Okay, now we've got a force. This is conformity, Amanda. It's conformity. If all the angles are equal, then the others are forced to be. Okay. So
look at your K2 and C3. They are equal. Why? Because of tan chord.
Look at that, beautiful. Because remember, this is a tangent, so that
equals
is equal to this.
And then we have to state it. Okay, let's write it quickly.
Okay, tan chord.
Okay, here, we have this, K2. Okay, let me write it quickly. C, we're saying, is this the agreement? K2 equals C3, and then is where we have, let's see. Okay, so we have tan chord.
Now that's what
And
it's
then-
good. This
then-
should
then
be
that is
exterior angle of the
exterior
triangle.
angle.
Yes, that's it.
You're thinking ahead. Exterior angle of a triangle. Right. Now, we can equate them.
Okay, now these are equal.
Do we have to write this down?
No,
This equal?
no.
You can just
You
convert.
see, look, those are equal and those are equal. So what does that tell me?
A2 equals B1.
Therefore, A2, and we've got it there, hey? A2 is
Right.
equal to B1. And therefore, we're not going to write that down. We can say, therefore, you say that AD is a tangent to the circle.
But they have to study it down.
Very
Write
important.
it down
must
as...
write down, You must write that down. Simply because if you look at that, this is a tangent. Because of that, therefore, what do we know? We know that AD is a tangent. You must write this down. Is a tangent to the imaginary circle ABK.
At A.
That's A. Okay, so watch out for that there. And very important, get your reasons in and that kind of thing. Now, the next one is actually quite a clever question. It's about similar triangles. Now, if you look at this, what does it say? It says there, Nelson, do you want to read that?
Prove that BC squared equals AC times KC if it is further given that BC is a tangent.
Okay, so let's have a look here. BC is a tangent. So we're going to take this all off here, and let's see what we've got here. BC is a tangent. So let's...
It's a tangent to the same circle
same
with
imaginary
circle.
Yeah. Okay. Now remember, we've just proven that this is a tangent, so we know already that we've got A2 is equal to B1, so we know that. There, and this is a tangent, so what do we know, Nelson? We've got, if that is a tangent...
Then this equals A1.
Now we've got that there, which is rather nice there. And remember, this is A, and that's B. D. C, okay,
right.
and K.
Okay.
Okay, now, to do this is interesting because we've got to prove that BC squared. So let's write down what we've got to prove. We've got BC squared is equal to, this is what we have to do, AC
times KC.
So that's what we have to do. Now, Nelson, what I would suggest, I don't know if you agree, is that break them out.
I was going to come to this point, AC, KC, and then you do your ratios.
And then we get the triangles quickly. Okay. So what do we know? We've got
BC, it means they're sharing a side there.
Okay, so it's BCAC. Is that a triangle?
BCAC, yes.
Definitely. Now, what I would suggest, guys, write this down here. Let's put it in alphabetical order, A, B, and C. Okay, now what have we got? Okay, if you look at A, B, C is A1, B1 and 2, and what's the other one? C2.
C2, yes.
Okay, we've got that there. Now, what's the other triangle? So we've sorted this.
BC is KC.
Okay, BC, KC,
BC, KC is smaller one.
It's that little one.
Yeah.
Okay, so then we've got, we can write BCK if we like, eh?
Yeah.
What's it, your BCK, BCK. Okay, now what is that there? BCK, B2. Okay, there, K2, and I think it's C2.
Yep.
Okay, now very important, we're going to match make these things. C2 is equal to C2. Do you agree, Nelson?
Yeah. Common
It's like a relationship. These three people go to a venue somewhere and say, listen, I'm looking for a girlfriend. And the thing is, what's happening? This guy says, C2 says to C2, man, you remind me of myself, eh? We've got so much in common.
In common,
okay.
Yes.
All right, and then what's this one?
Marks.
And then A1 is equal to B2. Okay, A1 is equal to B2 tan chord.
Yep.
And this is the weakest link. Okay, these two have to do it. Now, if you prove it, if you go through, you can immediately say...
In triangle.
Okay. In triangle ABC.
And BCK.
And very important, B... Okay.
Yeah. B, okay. Right.
Okay, BKC, that's very important. Now, very important, guys, it's the order. A, B, C. A goes with B. B goes with K, and C goes
with C.
C. Okay. Yep. Now, that order, Amanda, is so important. Do you agree, Nelson?
Informing the ratios there.
If you don't, you're not going to get this thing to work. Okay, so it's important. Then when we've done this, we can do what I call frog face. A, B, B, K,
B, C, K, C, A, C.
There's our froggy. Okay, see there. Can you see the frog there?
I can see it smiling there.
All right, so then we go A, B. So what's it, Nelson? A, B?
A, B over BK equals BC over KC equals AC over BC. And then we just choose the relevant ones.
Okay, then what do we want?
BC, I think the last two.
There we go. And then what do we have?
Cross.
Okay, BC. times
Times
BC
BC
is equal to AC.
AC times KC.
And there we
And we
go.
have BC squared equals that.
Okay, now AC times KC. And there we've got it. Guys, you can see. And watch out, okay, you didn't really have time to draw these pictures in that, but watch out. The important thing, I think, Nelson, similar triangles, and watch out when they vary the length as well. When they change, they give you this equals this, and you have to do a whole
And
lot of
again,
mathematics.
guys, don't forget to write your reason down, because we just did. We were discussing this with you, but just put the reasons here, guys. Why you're saying these are equal.
Yeah, you have to, when you've got that, you must, we're so rushed for time here, but you must state ABC. In other words, the reason A1 is equal to B1 because of the
blah, blah.
similar triangle, because of the tan chord, and C2 is T2 common.
Oh, okay.